This is a video about sets. We can define a set as a collection of elements, and the elements are often numbers. So, for example, if we have a look here, we often have these curly braces there, and we could have 3, 6, 9, dot, dot, dot. The dot, dot, dots are called ellipse points or ellipses, and each of these numbers here are elements. It doesn't have to be numbers, but they're the common things we encounter. So there's ways of referring to sets. And by the way, in this video, don't just take your Cornell notes. There'll be 3 quiz questions where you have to pause the video and write your answers in OneNote, please. Certainly by Wednesday's lesson, where I can check it. Write your answer in OneNote and write it in your own section in the individual space notes tab, and please create a page. Getting back to our content now, we have something like this which has a certain meaning. Okay, so you can see here we have some symbols, and that these have a certain meaning. This means the elements X. So elements, or elements X. This line here means such that. Sometimes that stroke is replaced by a colon, so you could have, instead of that vertical stroke, you could have a colon there, which you can see there in red. So it's elements X such that X is greater than 0. So that, what that basically means, all values greater than 0. So if we're talking about numbers, numbers greater than 0. The curvy brackets means the set of. So outside here, together those braces mean the set of. So the set of numbers or set of elements such that the elements are greater than 0. So the set of all numbers greater than 0 would be the common interpretation of that. Below I've added in another variation. So what we have here, we have X and that curvy looking E, that means element of. Okay, so that means X is an element of. And you've seen the boldface R before, that means real numbers. So X is an element of real numbers, and then again such that X is greater than or equal to 3. So these are conditions, so we can actually write conditions in this format as well. So we have here the type of element or the type of number, and the conditions or condition. Okay, so this one is X is an element of the real number system, or X is a real number, and it's a real number from 3 onwards. Okay, so, or another way of writing this, all real numbers from 3 upwards. We could write that alternatively as a number line, or on a number line. We have 3 there, and it's all things from 3 upwards, so we can look at including 3 and going along that number line, and it continues on. Or another way of writing that would be square bracket there, 3 and positive infinity here. It all means the same thing. That's curvy there. So when we have a square bracket, that means it's closed at that end, open at the other end, or in other words, that means it's exclusive because you can't reach infinity. It excludes infinity. It excludes that number there and includes that number there. So these things are all the same information explained or presented differently. I would like you now to have a look at the question, well, the information here, which leads to my first question. I would like you to call this question 1 and post your answer in your individual space notes under your name. You can see the arrow there, and it's pointing to a sentence. A set of all k's that are a member of the integers such that k is greater than 5. I would like you to write that in set notation in a similar vein to the one just above it. So try that, pause the video, write it in as question 1, write the answer to that. Now that you've finished that question, unpausing the video, let's look at some more examples here. So some further examples. We can have things such as this. The set of all x, or the set of all elements that are real numbers such that x is greater than or equal to 2 and x is less than or equal to 6. So we would have several ways of writing that. One way is to write it as a set. If you think about real numbers, it's basically difficult to write that as a set with elements in it, isn't it? Sometimes we can. So that one very difficult to write in that way, but we could instead write it on a number line. And if we've got 2, 6, basically it's the values in between that, and it does include 2 and 6, so we have to include 2 and 6 if those 2 points are 2 and 6. We can put the other points in, 3, 4 and 5. Okay, as a guide, 2, 3, 4, 5, 6, but it's all, because it's real numbers, it's all the elements on the number line, so that's why I couldn't write them as in discrete values in the set, because there's an infinite number of values there, but I can write it as a number line. So it's a continuous amount and it's inclusive. Sorry about the dip in the middle of that. Here's another example in blue. We've got x is an element of integers, z, such that x equals x squared. Now we can write that because it's discrete integer values, and also there are only 2 elements in that set. The only possible elements are 0 and 1, because 0 equals 0 squared and 1 equals 1 squared, and there are no other elements there. So that one's easy to write as a set. Further examples. We have x is a set of reals such that, here's an example of such that x is less than or equal to 2 or x is greater than 3. Again, if we looked at that one, because it's reals, it's easy to write a number line, draw a number line there, and we look at, well, the number line is continuous to infinity at positive and negative. What would we have? Well, it includes 2 and everything less than, so we're going down that way, and that'll have to be a 2 there, and we've got 3 here, but that's not inclusive, it's above 3. Sorry, it's an exaggerated hollow dot, hollow point, but it goes from 3 above, so it's got this discontinuity in the middle here. Second question. When you've answered this question, please put your answer as question 2 in the individual space tab. We have a number line here, -20, there's a blue zone up to -10, hollow circle and full circle at -20 and -10 respectively. Rewrite that as something in set notation. Pause the video while you do this. Third and final part of the video contains some symbols that you need to be fluent with. There are a lot of symbols in set notation, but I've kept it down to the essential ones that you need to know. So what we have in this table here is a symbol, the meaning, and examples. Okay, these are ones you need to know, and in the examples they've used that is the set C and that is the set D. Okay, some of these we mentioned already. The braces mean a set, the set of, it's a collection of elements. U is union, which is both, so C in union with D is both of those sets put together without doubling up. Intersection is the one common to both sets. In a Venn diagram, that's where you'd have overlap. Now you've got subset and proper subset. We need to make a distinction between those. You can notice that subset has the extra stroke below it and proper subset does not. The distinction between a subset and a proper subset: a subset can have some or all of the elements. So if we look at D above there, it's 3, 4, 5, and 3, 4, 5 is a subset of D. It's one possible subset. 3 by itself could have been a subset of D as well, but it can include the whole set. So a subset can, the larger subset is the same as the whole set that it's derived from, whereas a proper subset cannot have the whole set as its proper subset. It can only take some of the elements. So it could have 3 by itself, or 5 by itself, or 4 by itself. It can have 3 and 5 and 4 and 5 and any combination, but it cannot have the entire set as a proper subset. Then we've got the next one. A stroke means not a subset, and you could do the same with proper subset too. Not a proper subset by putting a stroke through, a bit like not equal to, that you're already familiar with. That we've already seen that one. That's element of. Stroke means not an element of. That means disjoint or empty set, which you see there. There's no intersection between those two. The intersection is an empty set. U is the universal set, the set of all possible values, but of course there is a parameter in the area of interest. Irrelevant things aren't included in that. We've seen such that the stroke and or the colon. This is an important one. Upside down capital A means for all. For all values of x greater than 1, x squared is greater than x. Okay, so for all. Reverse capital E, there exists values of x such that x squared is greater than x. Lastly, therefore. You've seen that before. There is an inverted version of that which also means such that. So the inverted, let me write that again. The inverted one means the same as that, but it's used differently. The last part of the video and the final question I've just put here in black, and it starts there. There exists x such that the square root of x is greater than x. Is this true? Explain. Write your answer in your individual space tab.